Good morning, good evening, and hello from the .NET or on .NET Live. Welcome to 60 minutes of unscripted .NET entertainment. Our mission is to empower the .NET community to achieve more. I'm your host, David Pine, here with co-hosts Myra Wenzel, this way, and Cam Soper. And today's special guest is Prakash Pattisapu. Prakash, go ahead and say hello to the world, and let's do a little introduction.
Yeah, hello friends. My name is Prakash Pattisapu. I've been in the IT industry for about 20 years now, working since .NET 1 actually. So worked in investment banking, e-commerce, healthcare, different industry verticals. Been in architecture, enterprise architecture for about 8 to 9 years now. So enjoying so far with the advent of cloud computing and cloud native architectures. I think it's an exciting time to be here. Thank you.
Awesome. Thank you. And I believe that we've got some related bits that Cam Soper is going to be sharing with us today.
That we do. Okay, so this week's related bits, which we do have a URL ticker for, there it is. This week's related bits is a Microsoft training module. We used to call these Learn modules, but we've rebranded in the Microsoft Docs and Learn. We're now all of it's Microsoft Learn, and the interactive training modules are just training modules. So this is a training module that was actually co-written by yours truly, along with our other co-host, Scott Addy. This module is basically your introduction to cloud native ASP.NET Core microservices. So when you come and use this training module, we're going to walk you through the scenario, which is a real microservices application. It's like a reference application that the .NET architecture team put together called eShop on Containers. And what we do is we give you a dev container that you can run locally or in GitHub code spaces. And that dev container has all the tools you need and all the source, all pre-configured. And the very first thing you're going to do is you're going to run a script, and I show you where to run the script. You're going to run this script, this quick start script, and about 5 minutes later, eShop on Containers will all be deployed and ready for you to walk through this training module and make one small modification to it. But before we talk about that, we talk about the architecture for the application. So like, again, this is a full-blown microservices application that it has these nice boundaries that are well defined, and we use various techniques, and I'm sure Prakash is going to talk about today. And what we walk you through is the architecture of the application, how it got deployed, and then we make one small change. I'm going to skip ahead. a little bit to where we actually show the change. We make one small change. So here's the code that we give you. We make one small change to implement a coupon feature in this online storefront site. So you make that one small change, you deploy it, and you test it, and you've done the training module. Now, this training module is part of a series. It's actually part of a learning path of microservices on .NET that has 9 modules to it. This module is actually the third one. And all of the 3rd through 9th modules in that learning path use this same architecture, use the same dev container, the same code base. So you're going to be working with the eShop on Containers application to implement a whole range of microservices topics. And we talk about, in that learning path, we talk about things like, of course, this is just like the introduction here, but we talk about resiliency. We talk about API gateways. We talk about I am blanking out. Storage. So there's at any rate, we put a lot of work into these Microsoft training modules for microservices. Hopefully, if you want to see more of what Prakash is going to show you today, you can go check this out later. I'll throw the banner up there one more time with the URL, and with that, I think we can get to a hallway track.
Let's do it.
Okay.
All right, David. You're
Hallway
the
track time. Yeah. So to just kind of paint a visual for people who are unfamiliar with the show, the hallway track is really to encompass or embody the gatherings that would happen organically at conferences. So if you've ever been to a technical or a developer conference, there's different sessions that go on, and you have to sit there kind of quietly and maybe ask questions at the end. This is kind of taking that and flipping it on its head and saying, we're bringing this to you. So Prakash is here. If you have questions, use the chat. We'll make sure that we ask questions and answer those. And so let's jump right into it.
All right. Thank you all. Thank you for the nice intro. So today we're going to look at microservices on .NET 6 and K8s, enabling a better developer in a loop, 0 to 100 in 30 seconds. So let's see if we can hit the clock, right? So before we start the actual demo, I just wanted to level set here on take like 2-3 minutes of the time to talk about cloud native systems. So cloud native systems are primarily driven by business needs. When somebody talks about cloud native, you must have seen a lot of articles on Microsoft and YouTube videos. What is a cloud native system? Essentially a set of microservices that are driven, basically domain driven, small independent modules, right? But is microservices the answer for everything? Probably not. And if you have a small size company that doesn't want to dabble with the complexity of microservices, you don't have to do it, right? So it's primarily driven by business needs, right? So cloud native systems provide scale and improve agility by creating autonomous subsystems. These subsystems are also called microservices. I just want to take like a couple of minutes going through the pillars of cloud native. So the first one is cloud infrastructure. You have various infrastructure components. Let's say you have your regular bare metal systems. You have VMs on top, and you probably have Docker containers. So the cloud infrastructure in a cloud native system abstracts all of these, and then they would treat this infrastructure as disposable commodities, right? So it's your classic pets versus cattle debate, right? So when in the good old days, when you have infrastructure, you used to name them with fancy names, right? So now you just treat them as cattle, right? So they come in and go. So it's all abstracted out. And when you talk about microservices, you have 12-factor or the 15-factor app. Off late, if you look at the Microsoft website in the MS Learn series, you would see 15 factors, not just 12, right? And once you take the path of microservices, there are a bunch of things that you need to solve, right? Some of the hard questions like database per service, multi-tenancy, event-driven, how do we aggregate data, Am I allowed to do distributed transactions? And there are a bunch of other things, right? And I just did not have, I promised myself that I'm going to have only one slide today. So I just wanted to cram in as much as possible in this. And then you have automation, DevSecOps, QA automation, DevOps, etc. Right? So you have the entire release management, SRE, site reliability engineering. That is its own branch of study, right? It's a big ocean there. And of course, we have the follow the well-architected pattern. I just put in a link there for learn.microsoft.com, which talks about reliability, security, operational excellence, cost management, and efficiency. So that is, I think, a fantastic learning resource. Please take some time to read through that. So with this out of the way, let me switch over to Visual Studio. So this is going to be demo heavy in terms of the number of steps that we're going to execute live. So hopefully the demo guards are happy today and everything goes smoothly. Yeah. All right. So my approach as an architect over the past 8-9 years has always been to templatize code, right? So if you're an architect, I know exactly, what goes through the mind, right? So you have a lot of developers working in various domains. You have, let's say, a classic e-commerce shop. You have payments, orders, shopping carts, so on and so forth. You want to level set everybody. You want to bootstrap these microservices in a common way, right? Although you can do lunch and learns and then evangelize the best native patterns, based on my experience, the best way to do it is templatize the code, right? Give them a solid foundation, either using shared libraries or sidecars. Give them that foundation so that the developers don't have to reinvent the wheel there, right? So you have prescription opinionated samples on let's say PubSub, distributed tracing, right? Observability and traceability, mediator pattern, for example. So all of these will be baked into our template, and all the developers need to do is select the template. It's a multi-project template, by the way, and then it will be there is a new framework that Microsoft released recently called Project Tie. I'm going to demo that. So I'm going to use Project Tie to stitch this local orchestrator on your machine, and then kickstart. Hopefully 0 to 100 in 30 seconds or less, right? So let's just go ahead and start, select the cloud microservice project template, click next. Then let's say I am going to create a template, a microservice called orders. All right, so let's give it a few seconds for the project to be bootstrapped. Okay.
So with your ultra wide monitor, you're going to need to really zoom in so folks can see.
All right, so let's see. Okay, so now maybe if I center this in the screen, is that helpful?
Well, I was thinking just like font size, but
font size. Okay. Should I use the magnifier or yeah? Go ahead.
Inside Visual Studio, there's a once you open one of the files, you'll see.
Okay. Yeah. Is the Solution Explorer visible at all? I mean,
yeah, it's kind of hard to see. So I guess if the Solution Explorer itself isn't too relevant to how, are you just trying to show like the organization?
Yeah. So just the code organization, what is being created.
Yeah.
So let me just walk through what is being created here.
And maybe use magnifier for that. But then once we get into code, zoom in on the files. Yeah.
All right. Let me see if I can switch on the magnifier. Okay. So
yes.
is that good?
Yes.
All right.
It is much better.
Okay. So here, this template, what it does is it'll create all the build assets, the charts, the Helm charts, the migrations, the API project, the domain project, any integration events through the message bus, and the infrastructure project, which is basically your base classes and all, ready to go, right? So the developer doesn't have to do anything. Basically the template is organized in such a way that whatever the name of the microservice you give, that it's going to substitute the name. This is done using the Vizix template. Vizix is a very, very powerful feature. It basically stands for Visual Studio Extensibility, where you can customize Visual Studio, add your own menu items on right click, or even to the root menu bar. You can create project templates and whatnot, right? So I'm going to actually, I'm not going to go through deep into this template itself. I'm just going to show that there is a Docker file here. If you expand the Helm charts, you can see the templates in some of the Helm stuff here. And then there's my initial migration script. And then there is one small table that is actually created, and in the API folder you have the application. We set up our commands and behaviors and whatnot. Internally, it uses a mediator pattern in the controller section, right? So yeah, so this is the project. So let me go ahead and run that. I just hit F5. All right, so it's starting up.
And just like a question. So when you selected the create new project, what was the template that you chose for this one?
It is a custom written template.
Okay, so it's a
Yeah, so
custom
it's
template.
custom template. That I use for bootstrapping microservices. It's a multi-project template. It's called Cloud .NET 6 multi-project template. So it basically bootstraps everything in one solution file along with the Docker file necessary to do a deployment. Right.
Got it.
Yep. So here you can see that the application is getting loaded, right? So if I were to go to, okay, so let me go ahead and cancel that. All right, how do I get out of this magnifier?
Windows key minus.
Windows key minus, got it. All right, okay. So now let me go here, and then let's go to localhost 8000, right? So here you can see that we have the DB store, we have the orders API.
Prakash, could you zoom in on this
Sure.
window too?
Yeah, just like control scroll wheel.
There you go.
Yep.
Perfect. Much better.
Is it good? Yep.
Perfect.
All right. So here, the project Thai, what it does is it'll create a local orchestrator for you, right? So the orders API project that was just created, it'll automatically orchestrate your service, your microservice, and a Postgres container for you. The reason why it orchestrated Postgres is also because I know that I'm in Visual Studio again, but let's see. Hopefully, I can zoom in on this.
Mm-hmm.
Okay, so now you can see that I have a file called thai.yaml. This file describes, what services we are actually going to bootstrap here. So the number one service is we have the orders API. We have port bindings here, API services. We have the DB store. We have Postgres here, with the default password. And I'm mentioning here that we have the orders API, right? And then basically it uses this thai.yaml to bootstrap everything, right?
I'll be honest, this is my first time seeing Thai. I certainly have seen, we've talked about it a lot, internally, but I've just never had the time to use it. And that file reminds me a lot of a Docker Compose file.
Correct. So this is actually equivalent of Docker Compose, where you can compose containers. The biggest difference between Docker Compose and Thai is kind of oriented towards containers and .NET projects. So basically, you don't have to containerize your app, your C# project. You can directly reference orders API, for example, and then you can directly reference your C# project. So it'll start your web host using the CS proj file, and any other containers that you actually create as part of the thai.yaml will be automatically bootstrapped for you. So basically containers are optional here. You can directly reference CS proj files. So you can see that this DB store is a container, and then orders API is actually a project. So if I were to click on that, it'll automatically create a Swagger endpoint, because that's in the code actually, right? So I'm exposing a Swagger UI that publishes an open API specification. You can see that if I click on orders, try it out, one execute, right? So you can see that one is not found, 404, right? Because I did not create any. So if I were to go here and say, create a project, like create an item here, right? Let's go ahead and say execute. So you can see that validation failed. So I have the validation module using Fluent Validator automatically built in as part of the template, right? So here, when you get a 400 response back, you have validation failed. The quantity is, quantity range must be blah, blah, blah. Amount should be that. So let's go ahead and update this quantity and amount to like so, execute, right? So you can see that I get a 200 response back. Now let's go to orders here and say execute. You can see that we now have a response body, right? Now I can use the same thing to do a HTTP put operation for update, right? So go to orders, updates, try it out. Let's put the amount to be 2, execute, it's updated, right? So if I were to go down here and then execute, you can see that the quantity is now 2. So basically, it created an end-to-end solution for using Entity Framework Core, the mediator pattern, and all the, let's say you have a mandate that every controller in your API project should inherit from a base controller, right? Or you are prescribing to the developers that, hey, this is how you do distributed tracing or structured logging, for example, or this is how you do PubSub. You can build all of this into a template, and then the developers, would do a .NET new template name, or just do a file new, and then all the entire boilerplate code will be written for you. All the developers have to do is just focus on the business rules, and that's where the domain project comes into play. So
now at
yeah, go ahead.
development time, all of these all the services behind this are all running on the metal, right? These aren't running in containers at this point.
At this point, they are not running containers. I'm going to get to that in a minute,
Okay.
because we do have a Docker file here.
But before we do that, real quick, Prakash, we do have some questions.
Sure.
Lots of people are asking about this template. They want to know, can they get this template? Is it public? Do you have a link that they could, access this and play with it?
Not yet.
Okay.
So I still have some work to do on this one. So that is not public yet. But I may release it in the near future. So that's the plan. Yeah.
And you mentioned .NET New. So can you use this template with the .NET CLI as well, or is it just the VS?
Yeah, it's just the VS for now. I haven't integrated that with the CLI tooling, but I do have that in my personal roadmap. So yeah. Okay, so I mentioned that all the developers need to do is, again, I know this is tiny on the Solution Explorer side. We have this. Again, this template follows the domain-driven philosophy. We have an orders entity class, that derives from the base entity that implements an aggregate root. Aggregate roots are in classic domain-driven design philosophy. They combine multiple entities that are glued together using a common bounded context, right? So before you even write a line of code in microservices, based on my experience, you really have to get your functional architects together and discuss, what your service boundaries are, right? So hopefully, before when you bootstrap a solution like this, you have done all of that. You did your event storming sessions, identifying all the events that this service is going to emit and consume, and the exact service boundary, and then you start coding, right? So hopefully you have done all that, right? So again, this template it inherits from the base entity class, and here we have a custom method, called validate entity rules. Again, this class is immutable because it has private setters here. You instantiate the class using the publicly available constructor, and then if you have to modify any of these business rules, you have to call the validate entity rules function, right? And then once this function has been run, it'll set the is consistent is equal to true. That's like a flag to the runtime to say, hey, okay, this entity is consistent. Now I can persist it to the actual database behind the scenes, right? There is a clear prescription on where the developers need to put their stuff, right? So the developers don't have to think too much. They know exactly the service boundary. They just need to keep on adding their entities, their aggregates, and so on, their value objects, for example, and then publish the code. right? I'm going to come to code publish towards the end of the presentation. This is only for the local developer group, right? The next one would be, yeah, let me switch to the Thai dashboard. You can see that the Thai automatically puts these logs, right? So that the logs are automatically integrated. Anything that is part of the, yeah, you can see that this F5, you know, when I hit F5, it automatically ran the migrations too. So it creates an internal, you know, I use a tool called Flyway. It basically contacts, downloads the Flyway package and executes the Flyway tool, and then it does the create table. If the Flyway schema history doesn't exist, it actually executes that, and then it creates the orders table. So if I open Postgres here, we have the orders database here.
While you're pulling that up real quick, Prakash,
Sure.
out of curiosity, the Thai dashboard and the logs that you were just showing, is that something that's deployed as part of like your public solution, or is that like, you know, just when you're developing, you have access to this? And also, as kind of a follow-up, is there the potential for any like, you know, connection strings or something like that being output here in the log that you should be concerned with?
Yeah, great question. So it still follows the iLogger interface, right? So the logs are being output right now using Serilog. And I have one sync configured here for console logging. So it's basically writing to the standard out. So you can configure the log levels in your app settings file. But if the developer, right now, I don't have the necessary plumbing in place to mask any of the confidential data, but you know, that is probably, I could come up with something, but you can change the log levels and all that. And this is not wired up to actually write it to some external log store, right? You know, like log analytics or something. But right now it just writes to the standard out.
Awesome. Thank you.
Yep. Okay. So now you can see that it created it automatically created the orders table. Yeah, I mean, you know, if I did a view data, you know, we already created. Right click and say view data. Yeah, so we see, you know, I just created a row called 1 with string and a quantity of 2. You can see that there. I don't know if it's visible or not, but you know, it's I can't zoom in here.
Not really.
Okay. So there is one single row there. Yep.
We
Okay.
believe you though. It looks.
All right.
It looks. I mean, it looks like there's something.
So that something is actually shown here. So you can see that, you know, I just did a get operation on this, you know, execute, you know, that something is being written here. So this is hopefully clear, you know, clearly visible, right? So
Yes.
all right, cool. So the next one I wanted to show is Thai logs. I've already, okay, DB migrations I've talked about. Okay, so let's see. Oh, by the way, Project I automatically integrates with .NET Watch. You know what that means is this automatically provides you hot reload capability. So for example, if I were to go into the orders controller and let me, I'm going to split screen let me switch on the magnifier here.
Well, I think you can control mouse wheel up on your terminal window, and that should zoom in on the terminal too, right? Or no?
I don't know if the mouse wheel up, but is it visible now or?
Yeah, I mean,
okay?
yeah, the code I can see, and I can see your diagnostics, but that terminal window is still kind of sad.
Okay. All right. So let me see. Let me make a quick code change here. So for example, when we give a wrong ID, which is where the ID is not there in the database, you know, I'm going to put an exclamation mark there. You know, as soon as I save that file, you can see on the right-hand side that there is a file watcher there, right? So it changed, file watcher changed, orders controller, and you know, it's going to trigger a build in the background, right? And then it'll automatically trigger the build, and it'll, you know, using the event pipes, it knows that it's listening on process ID, whatever that is. And then if I were to go back to the browser here, and then let's say I did something like that, which is not there, you can see that exclamation mark, right? So you can actually basically do edit and continue without stopping your, you know, debugger, right?
I love that. Yeah, that's awesome.
Yeah. So, and also this edit and continue feature is not just restricted to your main API project. Let's say I want to actually, let's take a look at this DTO, right? My orders DTO object, which is being returned as part of the get stream, is inheriting from the base DTO object. Let's say I want to do a prop here, right? And I'm going to create a property called my property, right? And if I go here and then do the magnifier again.
Can you do Control Plus there? Like, I think that will.
On the command window, because that's actually not Windows Terminal. That's the old Windows command.
Yeah, this is the command window. Yeah.
Mhm.
So Control Plus should increase the font size there.
If it has focus, no.
Yeah.
No, it's not doing anything there.
Okay. All right.
All right.
But
Well,
Yeah.
it
So
is
let
what
me
it
go,
is.
let me go ahead and save that file. Then that should trigger another. Okay, let me go ahead and do a control minus.
Don't mind me. This is me leaning in to see the window.
Yeah.
So,
I was going to ask while you're doing this, so you're kind of exemplifying like hot reload and changing DTOs. These DTOs, are these tied in with entity framework? So you're actually doing like a schema update as well?
a schema. Well, these DTOs are actually tied into entity framework, not directly though. DTOs are just like the name indicates, data transfer objects. So they are only transferred from the browser to the API layer, and from there I have a property mapper that will map it to the entity frame to the core entities, right? So I don't directly put DTOs into the database because it has to go through the domain object, apply the validation rules, so on. Right?
Okay.
Yeah. All right, so did this guy save? Yes, this guy was saved. Orders API running, orders API started. Okay, so let's see, it did not trigger a build. Let me go ahead and remove that on the right-hand side, on the left-hand side, actually. So, okay, so now save. All right, let's see if that new object came in as part of the payload, right? I think it will not because it did not for some reason trigger a build. Okay, let's go ahead and refresh this. All right, so it's one of the demo guards thing.
Okay, no worries.
Yep. So it's basically, yeah, you can do the .NET Watch. It automatically does the .NET Watch on dependent projects also. If it is working, you can actually go ahead and modify any of the projects in your solution file. It should automatically reflect that. So that's what.
That's awesome.
Yep.
I did want to share with you that there's a lot of people who are watching that continue to ask for the template, that are really excited by the template. So
I will. Yeah.
They're asking where you're gonna publish after you're done with the template. So
I'll see. In fact, this was also part of my day job, right? So obviously, I need to get some approvals there. Yeah, I will try my best. Hopefully in the next few days. Yeah.
And there's also a question here from Nevin. Is ORM the go-to option with microservices, even if I use Oracle or other database than SQL?
Great question. So I've seen developers use Entity Framework, especially with the rapid speed improvements that the team is doing. And I've seen people use Dapper, not to be confused with the Dapper.dapr. It's DAPPER. It's a different framework for data access, which is faster than Entity Framework. So basically you can use whatever you're comfortable with, but Entity Framework is like it's like a Ferrari, right? It does a lot of things. It maintains state. It keeps track of your chain set. So it does a lot of things. If you're comfortable using Entity Framework and LINQ, by all means you can do that. But once you employ the microservices model, my advice is your microservices, by the word, indicates that it's a very thin service boundary. Usually you're dealing with 3 or 4 entities in your core domain, right? And everything you have already divided your main domain into, let's say, 10 or 12 different services. So the actual operations that you do on a single service are pretty minimal. And most of your communication would be happening behind the scenes using patterns like eventual consistency or event-driven systems, right? So where you publish an event, something changed in your core database, you publish an event that will be caught in Kafka or Service Bus or whatnot, and then the data will be synchronized to other services, and then you have to use some kind of an API gateway to aggregate the data across multiple services if you want to do an HTTP get operation, right? So that is usually the pattern that folks use. But for your normal data access purposes, either one would work fine. All right. What's next? .NET Watch is done. Oh, in fact, you can let me go ahead and switch this off, and I'm going to start it again. On the right hand side, I just switched off the and I'll do a time check here. Okay, so we are already at 12:35. I was going to say you can attach the debugger to this. You can attach a debugger, step through the code. If you were to do the local debugging, you can do attach to process, and you can do cloud.orders.api attach, and then you can just step through the code, right? So that's one more thing you could do.
Awesome. We got another question here real quick, Prakash.
Okay. Yep.
They're saying how many projects are in this solution here for the template?
There are actually 4 projects right now.
4 projects. So okay.
The API project, domain project, events project, and the infrastructure project.
Awesome.
All right. So now let me go ahead and close that window. Yeah. Okay, so now the second part of the presentation is I'm going to bootstrap a second microservice, okay, called payments.
So you use the same custom template that you used before.
Correct. So I'm going to quickly show service discovery and how it works using Project High. So I'm going to close all the windows here. Okay, so this is the payments. Let me do the magnifier again. So this is the payment. So you can see that this template is now customized for payments. Although the internal details are still the same, it still has the same single entity, the aggregate root and all that, but all your namespaces and all your project names are now dependent on the service name called payments, right? Okay, so now let me open up my code file. And okay, so let's open up my .NET Live folder. I have a tie.yaml here. You can see that.
Sort of see it.
Sort of. I know. So okay, okay, so this is the payments project that was just created, right? And this is the orders project that was just created, right? And then I am going to open this file, code.txt. I'm not going to do live coding today. Sorry about that. I'm just going to copy that. And then I'm going to open another instance of Visual Studio. Okay, so I'm going to open orders again.
Don't you want to answer a survey now?
Yeah, I'm going to do it right after the call, I promise.
Why would he do that when he's on the phone with us right now?
I'm joking.
All right, so here I am actually going to showcase a service-to-service call, right? So I'm going to remove that error, system HTTP, right? So I have a method called ping payments, right? And then this is going to contact the payment service. I'm going to say new URI. Yeah, I promise I'll not be doing any live coding, but the template is missing a little piece.
I was going to say, that's what you're doing right now. Come on.
Yeah, the template, I just updated the template this morning, so I forgot to put the null coalescing operator there. So, okay. All right, so it basically uses the configuration factory using TIE. It tries to get the payment service endpoint, and if it's not found, it just uses the core DNS and Kubernetes. This is actually useful when I deploy the solution into a real Kubernetes cluster on a local machine. Yeah. So this one is, and I'm actually pinging the payments service from the order service, right? So now we want to orchestrate two services, right? Now TIE run watch. Before I do that, I think I get a feeling that some of the Docker containers have not been shut down properly last time, but I'm going to leave it there. I'm going to do a tie run on that, and I'm going to do the magnifier again. All right. So, okay, so DB store, yeah. So you can see that there are some port conflicts, right? So basically, whenever there are port conflicts, it's best to stop the debugger and then clean up your containers, right? So let's do a Docker PS on this. You can see that Postgres is running with.
And then for those that don't know what Docker PS is, would you mind sharing what that command does?
Yeah, so it basically lists all the running containers on your system right now. So these are all the active containers that are actually running on your system right now. So if I were to go ahead and say Docker, because I had a port conflict on Postgres, I'm going to stop that container, copy that. All right, so I'm going to clear the screen. Then hopefully this time it'll load the TIE run. All right. So now you can see that, just looking at these logs here. So it started the payment service. It also started the order service. And oh, by the way, you can also specify the number of replicas. Replicas is a concept that is unique to Kubernetes and Service Fabric, where you can have multiple replicas of your service for resiliency, right? For HA, high availability, right? Okay, so now that is Bootstrap. Let me remove the magnifier. Come here, refresh HTTP 8000. You can see that I have the payment service, I have the order service. Okay, so now if I go here, this is my order service. And then if I click on that guy, this is my payment service. Okay, so now what I'm going to do is if I go to order service, I have the pink cart here, right? So now if I were to directly execute this, this would probably result in a 404, right? You can see that or 400, right? Because I did not put the ping endpoint on the order service. So let me go ahead and do that. Okay.
And all of these services are still running. So you're going to kind of exemplify hot reload right now.
Correct.
Awesome.
Correct. Yeah. So payments control, if it works.
I didn't just jinx it at all.
All right. Let's see. Let's see. So I just put in my endpoint for hello for payments from the payment service, and I'm going to save it. Let's go back to, yeah, looks like it's building in the background. I know this command window is not visible right now, but it is building something. So now if I were to go to my browser and then hit this again, I should get hello from payments.
Hooray! Yay!
All right, so that is basically service discovery in action, right? So you can have multiple, you can orchestrate multiple services on the client, and then let them talk to each other. Although a word of caution here in microservices architecture, if you have service calls, let's say the client UI is talking to service A, and then service A calls service B, B is calling C, you have this dependency chain. Normally that's considered an anti-pattern in microservices because you're now having a hard coupling of service A on B, B to C, etc. Right? So you would obviously want to put some kind of an aggregator in front of the services that says the UI will call this API gateway or the aggregator, and then and then that will spawn the necessary calls behind the scenes to all the services, get the data, and present it to the view. Right? You don't want services directly calling one another. Of course, there are some exceptions, but I just wanted to demonstrate that particular pattern here. Okay, so now what's next? Yeah, so Project I also has an extensibility mechanism, right? So if I were to go to, I did have the TIE dashboard here, the TIE documentation. So you can have things like ingresses, distributed tracing. I think I may have time to show distributed tracing. Let's see. Let me go back to my code here. And I have extensions. I'm going to throw in an extension called Zipkin. Okay. Let me go to, I need to open my tie.yaml because that's the main file that I have at the root here. Okay.
Lots of viewers are celebrating your successful demo. They were.
Oh, actually the icing on the cake is still yet to come. Remember,
Nice.
we still need to deploy to Kubernetes. Let's see that goes smoothly. Let's see.
That would be a miracle, right? No,
that would be a miracle. Exactly. Yeah. All right. So extension's name is Zipkin, right? So let me go ahead and stop this process. Unfortunately, any changes to tie.yaml, you have to start and restart. There is no hard reload for tie.yaml itself, right? Hard reload is only applicable to your code. Let's wait, and then luckily my machine is fast enough, so it should come up pretty quickly. So the Zipkin container, I've already downloaded it, so there is no need to download that. It knows that it's already cached it in the Docker local instance. So it is now running. Let's go back to our browser and then do a refresh. Okay, so now you can see that there is a Zipkin host here, right? So this is a container that is orchestrated by TIE. So we have a couple of microservices directly, referencing C# projects, and we have a couple of containers. One is a Postgres container, second is a Zipkin container, right? You click on Zipkin, and these are the Zipkin traces, right? Now, since our ports have changed, let's go back and click on order service, for example, right? Now let's go and try to get number 1 again, right? 1 is not found, right? So let's go back to Zipkin and say run query. See that? So the project TIE automatically, it uses event pipes behind the scenes, and it'll gather all your distributed traces. So if you click on that, you can show, and then you can get a span of how long it took for that single service call to come from to actually go from HTML local to the remote, right? Now this will show us the total time. Do we have time to quickly do a service discovery with multiple hops, right? Let's see. Okay, let's go here, and then this particular endpoint is already there. So is there a ping cart endpoint? Yeah. So let me go ahead and do a ping cart here. Hello from payments, right? Zipkin, go back. All right, this should be showing multiple spans. Maybe it's still not up, but if this was working, basically you can see the spans from the HTTP, the browser, to the order service, and order service to payment service. I just want to show that, but for some reason that's the total spans is still 1. Basically, distributed tracing is a mechanism where you can trace your HTTP call from the origin all the way to your all your APIs, your external endpoints like your databases and your message buses, so on and so forth. They're all tracked by a single trace ID, for example, right? So that TIE has built-in features to do that. So that is the other part of the demo. Unfortunately, I was not able to show the span for the call from orders to the payment service. All right, yeah, it still does not show up. That's okay. All right, so I am going to go ahead and switch it down and then go to the marquee feature. Let's see. Okay, now I'm going to deploy to my local Kubernetes cluster. So this is my local Kubernetes cluster. I have a tool called, an open source tool called Lens installed, right? This is running on my local Ubuntu using WSL2. Again, that's a different topic of discussion, how to set this up. But basically, once it's all set up, this you can see your nodes.
Can you zoom on this at all, or no?
I can do the magnifier on this one. All right. So these are all, again, Kubernetes is a vast subject. Basically, Kubernetes runs something called pods. Pods have containers within them. And then, it packages up. A container is basically your Docker image. It packages that up and exposes that as a pod. Pod is basically nothing but a unit of work inside Kubernetes. And Kubernetes manages, using a control plane software, it manages all these pods running on a cluster of machines. The machines could be 2 to 2 million. It doesn't really matter, right? So here we are looking at the charts, and also before we dive into that, I'm going to quickly go and deploy this. So
as you're doing that, we do have a question, a two-part question. The first part is to avoid unauthorized access from the apps and other namespaces. Should they implement authentication with each service, or is there
absolutely.
some sort of magical wave a wand interprocess?
Authentication is normally handled through the API gateway layer, because API gateway or your ingress, popularly it's called ingress in the Kubernetes nomenclature, right? So you plug in your authentication module at the ingress layer, and that it has you can use like Istio or Kong or whatnot, right? And that handles your authentication piece, and that means any calls that end up inside your services are already authenticated, but you might want to do your authorization checks at the service level, basically whether that particular caller is authorized to perform that particular endpoint action or not, right?
Now, how do you feel about service-to-service communication? Do you feel like that needs to be authenticated, or, like I personally have the philosophy that the boundary of the microservices app is closed, so service-to-service communication is probably okay to leave unauthenticated. But what's your opinion on that?
That's a good question. So basically, by the time this first service has been called already, the HTTP context is already populated with the user's credentials, and the user is properly authenticated. But if, let's say, if the philosophy for the company is zero trust, right? If there is a zero trust security policy in place, that means I'm not going to ever trust any call coming into my system. I'm going to re-authenticate it. Then you might want to think about authentication at the endpoint level itself, right?
Mm-hmm.
But as a general rule, you can get away with, if everything is routed, is authenticated at the ingress level or the gateway level, internal traffic, you can apply mutual TLS, it's all SSL anyway, but you can probably get away with that. That's my take on that.
Okay, thank you.
Okay. So now you have this special button called deploy to K8s. Hopefully everybody is able to see that. This is one of the Visual Studio extensibility endpoints. That where I extended the Visual Studio right-click menu. You click on the API project. It says deploy to K8s, right? You click on that, and then we have this special window called .NET K8s deploy that actually builds your Docker container, right? It uses the Docker file that was bootstrapped as part of the template, and then it's actually going to publish, right? So it's actually building the projects right now. You can see that the Docker build step is successfully complete. It's doing it. Oh, by the way, I'm using Azure Container Registry in the background. So I'm actually logging into ACR, and then we tag the Docker image, and then it's pushing it to Azure CR.io payment service, and then I'm doing a Helm install. Let's see if it's successful. Hey, wow, the stars have aligned. All right. So basically, what this special menu item is doing behind the scenes is, it is taking the Docker file that was generated as part of your base template. It is building that. It is using Docker login into ACR. It's pushing the image there, tagging the image, and then doing a Helm deploy on my local Kubernetes cluster, because my kube configuration file is pointing to my local K8s, right? So if I were to go to Lens now, you can see that if I go to releases, payment service has been deployed, right? If you go to the pods, you can see that the payment service pod is now instantiated, right? So let's go to, let me switch off the magnifier here. And then I have to do some port forward magic here because by default the host file is not configured. So let me go to services here. I'll quickly do a port forward on the payment service. All right, forward. I'm going to forward it to 8080, right? Start. Okay, so now you can see that this port 8080 is actually coming from Kubernetes. It's not Project Thai anymore, right? So this is actually being rendered from inside the Kubernetes cluster. Okay, so let's go ahead and try it out. The endpoint, execute, right? One is not found. Let's go ahead and create a brand new payment. Just execute. Validation errors, the same thing. Let's do 5 and 6. Execute. Right? You can see that 5 and 6. Now let's go to the get endpoint and say execute. You got 5 and 6 back. HTTP 200. Right? So this is actually coming from the payments pod inside Kubernetes. Now let's switch to the orders solution, and let's do the orders deploy to K8s. All right. So while it's deploying, any questions on this? Do you see any questions, guys, in the chat?
So we have had two folks actually start the conversation about what is your opinion about Kubernetes versus Azure Container Apps, and more specifically, why would anyone use Kubernetes when on Azure, like Azure Kubernetes Service, when Azure Container Apps is a thing?
Yeah, it's a great question. So some companies have a philosophy where we don't want to be tied to a particular cloud vendor, right? So they want to use completely cloud agnostic tools while still using the cloud provided infrastructure components. So let's say some companies have that rule, right? So you might want to go with your own Kubernetes instance or unmanaged by yourself, right? But some companies are okay with directly using Azure, Azure Container Registry, Azure Container Apps. The underlying technology is still Kubernetes. That gets you the best bang for the buck, in my opinion. But that is completely dependent on the direction your management is taking in terms of using doing kind of I wouldn't call it a lock-in per se, but you're still dependent on Azure up to a certain extent because you are using the Azure provided templates, the ARM templates, and they're all geared towards Azure, of course. So if your company allows it, by all means, go for that because that makes your job really easier.
Awesome, thank you.
Yep. Okay, so let's see. Awesome, man, we're in a roll. So this is also deployed. Let's go to. Let me switch off the magnifier for a minute. And let's go to Lens again. So you can see that if I go to releases, order service is also being deployed. And let me do a quick port forward on order service on 8081. Let's do port service. Let's go to services, order service, forward 8081, start. Okay, so now this is 8081 running from inside Kubernetes, and then I'm going to do a ping card on this one, right? Try it out, execute, boom. So this is service discovery working unmodified inside Project Thai and inside Kubernetes, right? So what we have demonstrated so far is bootstrapping your microservices layer, multiple microservices using a single Visual Studio template. And then using Project Thai to do hot reload, service discovery, Project Thai dashboard, logs, and so on, and distributed tracing. And we use the Visual Studio extensibility model to deploy our generated microservices into a local Kubernetes cluster, and then showcase service discovery inside the Kubernetes cluster. So we are at
Awesome.
two minutes to the hour, and
Wow.
thank you so much for the opportunity.
That's awesome. And just so you know, just I'll share the praise. The viewers are Very impressed with this demo. They thought you did fantastic. So,
Thank you.
Yeah.
Thank you.
Yeah.
Thank you so much.
This
Yep.
was great. Yeah. So I guess I'll close out now. So thank you for
Well,
everyone.
wait, hold on. I do have 2 questions left, right?
Okay.
First question, I'm just going to pop up. Last question from a viewer. Are there any integration tests in this template, or any other tests at
Great
all, like unit
question.
tests?
No, that's on the roadmap. I do plan to add some integration tests and unit tests. That is not there in the template yet.
Okay. And the last question I have for you is just like to bring it all home. Of course, we mentioned earlier that the audience really would love for you to publish this template somewhere that they could get it. Where should they look, like, to keep tabs on you to see when you throw it over the wall for everybody to enjoy?
My GitHub URL handle is Pattisapu01. So yeah, so I'll most likely publish it there once the day comes. Yeah.
Awesome. Yeah, now you can close it, David.
I can close it now.
Yeah,
Awesome.
you have my permission to proceed, sir.
Awesome.
And let us know, we can help to spread the word about the template when it's published as well.
Absolutely. Yeah. Well, thank you for everyone for watching. Thank you for your questions on today's stream. That was awesome. So if you enjoyed this, please check out previous shows and other great .NET Live TV streams on dot.net/live. Tune in next week when Elon Danny will join us to talk about exciting updates to her .NET book study and her series called A Conversation With, and the importance of learning with intention. We're looking forward to that one. Thank you so much. Goodbye,
Bye,
friends.
everybody.
Bye.